We spent the last few classes working on solving equations. These were technically considered single variable equations. We didn't have to call them that because you didn't know about anything else. But today we're talking about the difference between single variable equations that we've been working with and equations that are called literal equations. So for example, this is a single variable equation. 3x plus 7 equal to 11x minus 5. That's a single variable equation. On the other hand, this 3x plus 7y equal to 18 is a literal equation. What's the difference between these two equations? If you notice, this second equation, a literal equation, has two types of variables. Even though a single variable equation has technically two x's here, they're both the same type of variable. That makes it a single variable equation. A literal equation has more than one type of variable or type of letter. A literal equation has more than one type of letter. So you might see x's and y's in the same equation. That makes it a literal equation. So let's practice trying to classify these two types of equations. If we look at the first equation here, to answer the question, what type of equation is this? Do you notice that you have both a y and an x going on here? You have two types of variables. That makes this a literal equation. In the second one, you have actually three. You have an a, b, and an h. Since there's three types of variables here, this is also a literal equation. And yes, fun fact, that is the area formula you learned about last year. Most formulas are actually literal equations. But if we look at the third one, there is only x's happening here. That makes this a single variable. I'm going to shorten that to single vars for single variables. That is a single variable equation. That's what we had been working with before today's class. The fourth one, you have y's and x's. Since there are two types of letters here, this is a literal equation. And yes, fun fact, this is y equals mx plus b form. You learned about this last year, slope-intercept form. Slope-intercept form is a literal equation. For z equal to 20 only has one type of letter, so since it only has one type of letter, it is a single variable equation. Single variable equations can be solved for a number, for a solution. And on the last one, even though x is squared, there are only x's used in this equation. That makes it a single variable equation. So there are two types of equations we'll be dealing with here now, literal and single variable. It is important to know the difference between them because since they are different types of equation, solving them means something different for each kind. To solve single variable equations, solving means that we're going to find solutions. We're going to find some number. The solution is a number that makes the equation true. That's how we've been solving all of our equations up until now. We've been finding a number or a solution that makes the equation true. We're looking for a single number, x equal number, y equal number. But for literal equations, solving does not mean to find a number. Solving a literal equation means that we are going to rearrange the terms of an equation so that the variable is by itself or is isolated. In this case, you're not going to have y equals some number or x equals some number. You're going to have something like y equals mx plus b. The y is isolated. It is solved for y the same way that it is solved for x in a single variable equation. But with a literal equation, you're going to have 2 or 3 pieces of the equation that are still seen, as opposed to a single number. So, single variable equations, you're finding a solution. For literal equations, all you're doing is rearranging the terms. That's the number one thing you need to know. Literal equations means rearranging the equations. So let's do some really short examples here just to see what I mean about the difference between them. And as a quick reminder, you can only combine or add terms that have the same base or letter or variable and power or exponent. So we're looking for terms that maybe have different coefficients but have the same base and power. Base and power, base and power. We'd be able to combine those things together. If they're not the same, you can't combine them. That's something really important heading into these practice problems here. Number 1 says, or all of these, we're going to solve the equation for y. First thing we have to do is figure out what kind of equation it is. So if we look at number 1, we're trying to see if this has more than one variable. It does not. It only has a y variable, so we know that all we are going to do is to isolate the y. We're going to do that by using inverse operations or moving it across the center line. When you cross the line, you change the sign. You'd have y equal to 14. We have found the solution for y. Because it is a single variable, we know that our answer should be y equal a number. But in the second equation, do you see how there is more than one type of letter here? We have x's and y's. If that's the case, then we're still going to try to get the y by itself. And to do that, we need to move the x across the center line. So we're going to subtract x. Cross the line, change the sign. But we just talked about the fact that you cannot combine terms that don't have the same base or power, and that 20 and negative x aren't the same base or power. So we're not going to be able to combine those things together. We're going to have to just write them down next to each other. Y equals 20 minus x. Totally fine. By the way, you may also write this in mx plus b form and switch those around. That's also an acceptable way to write your answer, because I still have a negative x and I still have a positive 20. So let's see you try. On number 3 and 4, I want you to identify if they're literal equations or single variable equations, and then solve it appropriately. Here you can see my work. Number 3 was a single variable equation because there was only a single letter of y there. So we divided by the coefficient of 10, which is our solving rules, and we ended up with the solution of y equal 10. But in number 4, we actually had two types of letters there, which made it a literal equation. Since we're solving for y, that means we're trying to get y by itself. All I need to do is move the term 5z bloop across the center line. Cross the line, change the sign. It was negative, and now it's positive. Now, this is important right here. 37 and 5z cannot be combined together because they are not like terms. The 5z has a z attached to it, and a 37 is a good old-fashioned number. We can't combine them. It's like apples and oranges. So we're just going to write them down next to each other. Then as the last note, you can write this one as 37 plus 5z, or flip those things around and have 5z plus 37, so that this mimics y equal mx plus b. But it doesn't matter which way you write it, they are both correct. Remember, the goal of today was to be able to determine the difference between single variable equations with one letter or literal equations with multiple letters. See you in class.